Hello, everyone. First of all, I would like to thank you all for taking the time to be here. My name is Anderson Mota. I'm the head of technology architecture from Itaú. Also, we have here with us Gus Santana and Robert Fuente from AWS. We are here to talk a little bit more about the program of resilience that we have created together and share with you guys a little bit about the lessons learned of the creation of this program. So here's the agenda. Before we get started, I'm going to talk a little bit more about the journey of the bank Itaú Unibanco, what it is. Also, then we're going to go through the Resilience Evolution program. And then I'm going to have my colleagues here that are going to explain a little bit more and dive into the semantics of this program. So Itaú Unibanco is a financial institution of 98 years from Brazil. We are the largest in Latin America. We have presence in 20 countries and presence of 20 countries. Our main operations in Brazil, where also are the most valuable brand in there. We're valued at $7 billion with 65 million customers, of which 20 million customers are digital customers only. We also have 100 employees with 14,000 employees only in tech and 4,000 business services. When I say business services, I mean all the services that we offer to our customers and they can consume, such as open a bank account, getting a loan, or any other financial operations that a financial institution can provide. So by observing the behaviors of our clients in the consumption of these business services, we saw that their expectations have evolved, and now they value more for experience rather than just having a functionality of a product or a service. And in order to be more competitive, we need to be more digital. Because we think that digital technology and architecture better connect us to our customer. So what does it mean to be more digital after all? It's to put the customer at the center of everything we do, using the data that we collect through our applications to better understand the customer's designs. To be quicker respond to our customer expectations, we prioritized an agile methodology to allow shorter cycles of experimentations and also to delight our customer, because there in the bank, we want the customers to love the features and the products that we are offering them. So, of course, we are a bank of 90 years of history, meaning that we have a lot of monolithic applications that we somehow are trying to decoupling them into microservices. And that's exactly what we are doing, something that is not easy, but is exactly part of our journey. Also, we think that we need to be data-driven and work more with observability. Having the data, if we structure the way that we get the data from the applications, we could predict some of the problems, and before they happen, we could work more proactively rather than reactively. So, talk a little bit more about our journey. Back in 2016, we started working with frameworks in our private cloud. And we invested a lot in our data center. We have 3 data centers, which is also the largest in Latin America. But then we were seeing that we need to be more agile in order to be more competitive. That was somehow slowing us down to have everything on our own premises. And we knew that we need to do something about it. So we started back in 2018 restructuring the way that our teams work. to be more agile. So we structured them to work in communities or tribes and start changing the way of doing things. So since in 2020, we came up with a mandate defining a public cloud first, meaning that every new development of application needed to be written and born on a public cloud. So we wanted to push and start evolving our applications to something that could help us and allow us to be more efficient and get it to our customers in a quicker way, in a more efficient way, and that's exactly what we have done. Then in 2021, we start migrating things at a large scale. And we had basically two approaches. One is to get some of our applications to a lift and shift approach, but most of them, we wanted them to be rewritten to a DevOps. We call that DevOps condominium, meaning that we did not only want to use AWS as, I would say, like a collocation or something like that. We want the application there to be modernized before we could put that on AWS. So that's exactly what I've done. Right now, we have already migrated 45% of our applications to AWS, and we are aiming to, by the end of 2023, to have migrated 60%. So why, when we're talking about the Resilience Evolution Program, why? We're saying that even if we were speeding things and getting velocity to put our applications, our critical applications on AWS, we were getting impact. We were getting several impacts that would impacting more than 1% of our customers. 1% might not be, when we're talking about 1%, could be shorter, right? But when we're talking about millions of customers, that impacts us a lot. Not only the customers, since we are a financial institution, imagine you are going to pay something and your card does not work. This is something very stressful, right? Very overwhelming. So we knew that even if we were getting things better, we were delivering product features faster, we still were lacking to not have reached the level of excellence we were seeking to get things done to our customers. So then we start talking to the executives from both sides, from Itaú side and from AWS, and we came up with the idea of deliver a program that I would say AWS at that moment did not have. So we worked together to create that and to fulfill our desires. So that was quite good, actually, when AWS says that they work back, they love the customers and they work backwards. That's exactly what they have done with us. They saw the problems we were facing, and they started working backwards to a point that they could establish and create a program together that could solve and help us. And also, we needed more visibility to our applications, because there's something, when you're used to do something on on-premises, something, but when you go to a different, like public cloud, you need to do that in a different way. So how did we approach at the beginning? We chose 4 of our critical platforms and test them, start using them to test the model as an MVP to see if that would work. So first of it being PIX. What is PIX? PIX is instant paying systems in Brazil. It's one of the critical ones for those that are not using. Right now, Itaú takes care of 25 million transactions per day, and we process a volume of 30% of the counter in Brazil. The second one is the digital channels. Basically, the digital channels is a bunch of applications that make up our digital channels. Even like, it would be like a mobile or a desktop. And then we have the credit card operations. As you can imagine, this is something that is also very important to us. we have there 51 million transactions per day. And then we also have Kafka. Kafka is we have a cluster there that provides, that a lot of our critical applications rely on. So we thought that working on these 4 critical ones, we could build something that would make a sense to have inside the bank to other applications. So basically what we have decided was to create 5 pillars, 5 main pillars, and see if we can, from those pillars, start getting good results to those 4 critical applications. The first one being monitoring. We knew that we needed to evolve the observability of the applications that had pushed it to AWS, creating better dashboards. Basically, what we were trying to get rid of is when we had impairment of a service, we needed to not only rely on the experts from that applications, but we needed to know that in a way that an executive from our side could have something to look at and see exactly where the problem was. So we started evolving that. Say, okay, we need to get better logs. We don't want our experts need to go through CloudWatch, CloudTrail, and doing all the things that the technical guys, most of the technical guys love it, right? But takes time to get to the problem. So we wanted to evolve that, and we did. The second pillar was tests. We knew that when talking about IT, the problem is going to happen at some point, right? And you cannot actually think that you're not going to have any problems because you're going to get it. So we need to be prepared when the problem happens and see how self-healing your application is. So we created a framework of a chaos and start detailing it and start doing like, well, what is going to happen if I need to cut like a link here? Let's do that during a maintenance window and see what happens. So if our application crashed for some reason or something, we knew that we need to do something about it so it could evolve in our applications. That also we start doing that. So we create a solid and robust chaos framework to work with all the applications. The third one was the dependencies. Because it's quite important. We need to understand and know exactly the dependencies of your critical applications. Meaning that you want to reduce the blast radius during an outage. So if you have an impairment of a service, you don't want that a crash of one product from AWS start like crashing like the old system or different systems at the same time. You don't want that. So we start mapping the dependencies. You start also doing something that I think was quite important in this program as responsible for the architecture team inside the bank is to know the limits, the soft and hard limits from AWS. Because sometimes it's difficult for you guys to understand and get like a clear picture of all the limits that they have. And how could you design an architecture if you don't know the limits, right? It's something that I was like, well, you need to show me where your limit is, especially your hard limit, because I don't want to get to a point that I cannot keep on using this and I need to rethink and restructure the whole architecture. So that's something that also we did. The fourth pillar was enhancements. And when I say about enhancements, it's how could we got all the data from the third pillar of the dependencies and start working with the enhancements of the architectures so that we could get in our applications to be more reliable. So we did that. We said, whoa, okay, I have this, and I didn't know by the time that I've done this architecture that I have a hard limit or something. Or either I start structuring myself to work as a cellular architecture basis that I could replicate like blocks, and if something happens, I just load balance to another one and start using it. Otherwise, if I cannot do that, it's going to get to a point that I'm going to get trouble. And also, we came up with what I call service quotas that at some point, we got problems that when we reached the hard limit of AWS, that was too late. Because you reach it, we didn't know, the alarm was not quite clear, and was something that was not good to work on. So we create quotas of 75% of the created application. So when we get to that point, we got an alarm, so we could have like a feasible time to evolve or to change architecture before an outage happens. In the fifth pillar was governance. I cannot stress that enough. This is quite important because something is for you to actually fix and do things from the technical standpoint perspective, but the other problem is that when you need to start talking and change the behaviors of human beings, that's something quite difficult. And it's also very important for you guys to have the sponsor of the executives from both companies. Because if you don't have them sponsoring it and engaged in these calls, you cannot implement a program like this. Because you're going to get to a point that you're going to start like changing process that maybe talking about here in the bank, maybe was written like 30 years ago, 40 years ago. So it's not something that is easy to do without the sponsorship of our executives. And then what we have done, to finish that, summarize that, we have created a pillar called mechanisms. Actually what it does was, based on the lessons learned from the 5 pillars, we start implementing that as a mechanism, meaning that any other new development of applications inside the bank would get those lessons learned from the program, which, in my opinion, was the beauty of the program, was to create a mechanism and not only have this result for most critical applications, but enable it for you to do that at scale, at a large scale inside the bank. And so let's look at the data here. If you see on the left-hand side, we implement the pillars over 3 months, from March to May 2022. As you can see, we had brilliant results in the number of high-impact events, dropping 75%. And also, on the right-hand side, we had an equivalent reduction in the MTTR. So let's take a look into a more detailed way in exactly how we achieve these results. So working with us of establishing this program, we have the STL from the AWS, the single thread leader, Gus. The floor is all yours.
Thanks. Thanks, Mota, not only for the session, but also for the partnership throughout the year. Hi, everyone. My name is Gus. I'm a director for the Cloud Acceleration team in Latin America. And I had the pleasure of working with not only those 2 gentlemen there, but approximately 100 people that were engaged and involved in this program. Several of them are here in this room. So this is an attempt of representing 45 initiatives that belong to this program, right? So as you can see, the 5 pillars are there, and these are the main initiatives. That was a very interesting meeting that we had back in March 8th and March 9th, where we decide, based on everything that Itaú and AWS learned regarding the events that Itaú suffered, what should be done, right? Interesting decisions here. First, we had to distribute the activities throughout the year. We have chosen 24 as high priority. The method of selection was which have the most impact and that seems like shorter. Then we can do it faster, right? We could easily talk about those activities for 5 hours here, but because we have a 1-hour session, we're gonna talk about the ones in orange, okay? And right now, we are actually deploying the mechanism pillar. Like Mota said, we are trying to take everything that we have learned from all these activities, things that work and things that did not work, and try to scale them to all other 4,000 applications within Itaú. And by the way, this is the first time we're actually talking about this program outside of Itaú and AWS, so it's pretty exciting for us. So one concept that we have used, and this was a request from Fabio Napoli, Itaú CTO, was, okay, I need someone responsible for resilience on both sides, right? So we have decided to use a concept that exists inside Amazon that is called STL, or single-threaded leader. This person is essentially someone that wakes up thinking about a program, about a team, about a goal, right? And this person also keeps status, keeps track of obstacles, keeps track of the program as a whole. Generically speaking, in Amazon, an STL takes care of one team that we call two-pizza team. Who has heard about this expression before? Okay, so what is a two-pizza team? Essentially a team where two pizzas are enough to feed. So we are talking about 8 to 12 people. So this is like an optimum group where we can improve communication, let's say, right? So we have decided that this program would have one STL for Resilience and Itaú, so Anderson Mota. And from AWS side, we selected 2. One for architecture, that's me, and another one for operation and incidents, Robert, okay? And these are the responsibilities that were assigned to us. So first of all, escalate quickly whenever we need help from a service team or whenever we need help from an application team in Itaú. This was our function to do. We also had to identify areas of engagement as fast as possible. Also, be responsible for the failover testing and work essentially in 2 modes, right? Peace and war, let's say, meaning avoiding incidents, and if an incident was happening, driving all the attention to the incidents. And lastly, doing periodic reviews of the program with the executive sponsors, right? So in summary, we have decided to have daily stand-up meetings, right? So communication was key, and I think during the first phase of the program, I probably talked to these guys more than I talked to my wife, unfortunately. So, but it was important that us 3 were connected and understand exactly what was making the program to advance. So let's go into some activities that were key for the program and for the results that Mota has shown. First one, regarding chaos engineering. So luckily, Itaú already had an established chaos engineering team. But what Itaú requested us is that we develop a framework. So we have written together a 6-page document that today, in Portuguese, that today lives inside Itaú Wiki. In this document, we essentially detail these items here. First, the definitions of chaos engineering within Itaú. Then we also suggested a phased approach. So each development team should think about how to prepare for a game day, how to implement that game day, how to select hypotheses. We also created, because Itaú has 4,000 different applications and a lot of teams developing new applications by the day, right? So we also developed a maturity model to help prioritize which teams needed more focus in terms of chaos engineering. We also selected the tools, not only from AWS, but also tools that Itaú had developed for chaos engineering. And in the document, at the end, we put an example of a chaos engineer game day. The idea is that you build it, you run, is a slogan for development communities in Itaú. So they could take this document and actually run a chaos engineering game day. So as an example of the maturity model that we developed together, this shows 2 axes. One is chaos engineering adoption from left to right, and the vertical axis represents the sophistication of tests that each team was actually performing, right? So after a couple of interviews and questionnaires, we plotted that digital channels was more advanced and credit card operations were not that used to chaos engineering testing. So we focus our attention first in credit card operations. Does that make sense? So the idea is that we could use that for any application within Itaú. Some of the hypotheses that we have collected during the program, we are showing here. So for example, PICs. We wanted essentially to transform the unknown into the known, meaning we wanted to see how the application behaves when we have a mistake, when we have a failure, when we have something differently working. So for example, for PICs, Itaú decided that they wanted to understand how the application behaves when part of the traffic is running here in the US and not in our region in São Paulo. Also, what happens when the number of EC2 instances is reduced for what they call night mode? What happens to the traffic? What happens to the instances or to the lambdas, right? And this one was pretty interesting. It actually happened 2 weeks ago. So for digital channels, they wanted to test what happens when there's a major failure and then the channels are open again. Because all the customers are trying to make their operations, it's kind of like a wave of overload. So they wanted to understand how could they control, what breaks first, is it the front end, is that the back end? So Itaú actually had to request an authorization for the Brazil Central Bank to perform that test. So it's not only a decision within Itaú, actually it involves more compliance and regulations. As Mota has described, Itaú also has 45 of their workloads in AWS, but 55 on their on-premise data center. So the direct connect links between AWS and their data center are pretty critical, right? So another area that we decided to focus is how was Itaú testing their direct connect links. So we saw that those 16 links within São Paulo, Itaú did that procedure that is represented on the right every month. Essentially, record all the configurations, see how traffic is going, disable everything, and then coming back through shutdown interface and no shutdown interface, each link, and observing how the application is behaving with that, right? So after seeing that, is a really robust test plan. The program actually recommended 4 additional things for them. Number 1, this is an AWS solution that a TAM in Argentina had developed, essentially a monitoring solution that sees packet loss and high latency, and there's a CloudWatch alarm that detects anomaly. In case there is that detection, the BGP connection is disabled for that link. Another thing that we have recommended is what we call static stability, meaning that if a link fails, every month see if the other remaining links can actually absorb the traffic or not. The traffic, Itaú's traffic has a lot of seasonality. For example, December is a hot month, so that monitoring is very important. Another solution that we also recommended to Itaú was the use of direct connect failover test, which is documented essentially a way to test that BGP is breaking not only by interface shutdown, but actually from AWS side, we can simulate failure for a few minutes, right? So this made the test even richer. And finally, also the use of more than one link aggregation group for production traffic, okay? So these were pretty cool ideas that the program recommended to Itaú, and also we are doing it to other customers. Going to other critical activities, this one here, critical dependencies. We have actually dedicated a 2-pizza team to make an analysis of each application component and define if each service was a hard dependency or soft dependency. What is this? A hard dependency means if that service fails in AWS, the whole application goes down. A soft dependency means that if that service fails, there's a degradation, but the application will not come down. So after we have made this map, and this is an April snapshot, we actually recommended to the development teams, because Itaú has 4 releases per year. So we intended to turn the hard dependencies into soft dependency in the next releases. So the idea is to turn that into a mechanism, so each development team can actually do that by themselves. Make sense? Cool. Another, sorry, sir, we're gonna have a Q&A by the end. Is that okay?
Yeah, there were X's on that. I was just wondering what the X's meant.
Okay, so let's wait to the end. Sorry about that, okay? Another analysis that we have made regarding the blue-green or the new versions deployment, right? And after analyzing each of the core workloads, we have found that just one of them, like the digital channels, was using a procedure that came from the on-premise data center, meaning that a new version was actually receiving 100% of the users in a single AZ. That worked perfectly, but we thought, you know what? 3 days running on a single AZ may represent a vulnerability if something happens to that AZ. So Itaú quickly reviewed that application, and we absorbed that as a standard for the program. So every time a new application is released, that's one thing that we have to review. So the new strategy became this one. So we have the 3 AZs from the São Paulo region and 1 AZ from Virginia. And with a new release, we had 70% running in AZ1, for example, 25 in AZ3, and 5% in Virginia. And then in each day, we had a different distribution so we could test the new release in time. Does that make sense? Yes? Cool. Another thing, these 2 activities that I'm going to talk about now, they did not exist back in March. Actually, we saw that the program needed flexibility, so whenever something happened or an incident called attention to one thing that we were not covering, we included that in the program. So 2 things that were included around June, July, if I'm not mistaken. So 1, the Internet Core Account architecture. We have seen that the architecture that was developed back in 2020 could be enhanced perhaps after the program. We noticed, for example, the use of a shared VPC with shared service back there on upper right, that represented a fault domain. If we had a problem there, that could impact perhaps applications on all other accounts. Another thing that we noticed, Itaú was beginning to reach 5,000 accounts. So some of our services, they started to reach limits such as transit gateway. We started to reach limits regarding that. So what we did, we created a 2-pizza team, and this is the result. The next slide will show the result from that architecture. We also saw that new services like Gateway Load Balancer that did not exist back in 2020 could improve the load balance of the firewalls, right? So this is kind of what we did. For every 2,000 accounts, we separated a dedicated transit gateway. And that TGW was actually connected to one shared VPC. So accounts from 1 to 2,000 used a TGW and a shared VPC. So accounts to 2001 until 4,000, another pair. So what we created, we divided the accounts into 3 cells, and with that design, we will be able to scale to 8,000 accounts, 10,000 accounts, etc. Right? So this was fruit of the program analysis and the work that we have done together. Finally, an asset that seems simple but was very useful for us during the program is what we call service quota table. Essentially, this is a table that has one limit from AWS, from an AWS service, defines what is the limit, if it is a hard limit or a soft limit, or meaning if you reach it, if you reach the limit, you cannot go beyond, or you go into a non-recommended area. And what we have on the right side, how can we measure that limit? How can we create alarms if one element reaches 70% or 75% of that limit? So that simple table actually made observability a much richer thing for Itaú and for AWS actually. Okay, so to talk about observability, I would like to call Robert to show you very fancy screen captures. Thank you.
Thanks, Gus. Thanks so much, Gus. Great. So, hi folks. My name's Robert. I'm a Principal TAM for Enterprise Support, and part of my role within the single-threaded leader was operations and observability. This photo here was taken at the very start of the program. And as you can see, this is one of the control centers Itaú have spread out through many of the data centers. And what was really amazing, what really amazed me when I started working with Itaú was the size of this room and the attention to detail. So these dashboards have a wide range of telemetry. So from web users, mobile users, and also internet health. And it ties into all the applications that we worked in the resiliency program. To give you a sense of the scale, Itaú consumes approximately 1.5 billion metrics per day, and this is just in one system. So the scale here is pretty big. As Mota also discussed, transactions are a huge scale for Itaú, and they're a lifeline to resilience. So availability is central to Itaú, and it's something that they pay a lot of attention to. So one of the roles for being the single-threaded leader in the operation and observability was reducing MTTR. And this is the mechanisms that we wanted to try and review and see what we could experiment with and try and reduce the MTTR and mean time to detection. It was something really important for us. We had lots of discussions in these 3 days, and they led to some brilliant questions and diving deep into architectures and the challenges that we both companies had. So not just from an Itaú perspective, but also from AWS. Yeah, what could AWS improve when it came to observability and helping reduce the mean time to recovery? So we have, out of these conversations, we're going to be discussing 3 of those challenges in the next couple of slides. The first challenge, or the item that we discussed, was observability between applications and AWS. We really wanted to improve the time to detect, the time to move on to the investigation, and obviously the end result would be to have faster remediation. Detection, I mean, we all have alarms, but we really wanted to create these alarms that had more logic. So aggregation, resources. So not just the application, but what underlying AWS resources were these alarms, were these resources using that were triggering the alarms. We wanted to give the best information to the teams, so these teams could start investigating. And we could also engage service team members and Itaú specific teams. We also wanted to create dashboarding, telemetry, and other mechanisms to understand the health and availability of these systems. And we also wanted to understand what information was here. So is this an application problem? Is this a resource problem? Is it an AWS service problem? Are we seeing problems that are in a specific zone? Can we shift the traffic away from that zone? Can we move away from that service? Were some of the things that we were trying to get as data points to help us in the remediation. Another part was executive dashboards. During these talks, Fabio Napoli, the CTO of Itaú, challenged us in saying that dashboards should allow teams and executives who are not application owners a simple way to view availability and also have potential to be able to drill down. This idea was really interesting. And again, it points to the detail that Itaú has when it comes to understanding application health. We're talking about from the CTO down, they need and want awareness. This is something that was very unique in this situation. Another part was the support experience. Itaú's architecture is complex. They have thousands of workloads, millions of transactions, as Mota commented, with the Pix applications, credit cards, many dependencies, upstream dependencies, external dependencies. There's a lot of knowledge and context. Opening a support case and expecting a support engineer to have a response is a challenge. And we started to look internally and work with Itaú to understand if enterprise support was enough for these 4 workloads. So with these 3 challenges, we embarked on the road to understanding Itaú's critical workloads. So in order to create the first dashboards and to understand these critical workflows, it was really important for us to, number one, understand the applications, understand how they flowed, and even more important, understand the AWS underlying infrastructure. And in order to achieve this, Itaú and AWS ran whiteboard sessions where both engineering teams sat down and we discussed the architecture. So we like to call this the life of the packet. So we see the traversal of a customer connecting to Itaú's online banking and how they connect to the resources and dependencies within that application. And these conversations are awesome. I really recommend, all you folks to have this conversation with your TAMs and essays. The information for us is extremely valuable, and it helps us improve the service that we're offering. From these whiteboard sessions, we created our first dashboard. It was a very simple dashboard. This is a dashboard for the Pix application. And again, this was at the very start of the program. And our idea was to build something and to continuously iterate over it. This dashboard here actually demonstrates, with this dashboard, we were able to map down the critical workflows. And you can actually see this is a layered dashboard. So this is basically a user entering a specific application. We can see what stacks they're actually going through. And this is super important. And the other important part is that we understand which resources, AWS resources, are being used by that application. We are also aggregating views. This is at the very start. So we started aggregating metrics as well, which is something that's super important. We're not just monitoring a specific resource, but we're also trying to get some logic in here by using downstream components and also overlapping. So Itaú has many accounts, many accounts, and they have accounts for specific services. We were also able to map those accounts into these dashboards. Awesome. So dashboards are great, but if I have to go look at a dashboard to understand that we have a problem, we've failed, right? And this came up with the next part of the discussion was we needed alarms. So we needed to create alarms, and we needed to create high precision alarms. Like, we don't want noise. I mean, we already have enough noise, and we have thousands of applications here. Imagine that we're firing off alarms for all these thousands of applications. No one's ever going to read those alarms or do anything with those alarms. So again, we went back to Itaú's engineering teams to run another whiteboard session, but this time we did a little bit different. We actually demonstrated the dashboards we had created, and we sat down with the teams and went over the metrics, went over the anomalies that the TAMs and the essays had picked out. And we also used the dashboards for events that had occurred. And with all this data, we were able to come up with specific key KPIs for alarming. And this was pretty interesting because, again, we were validating what we understood from these discussions with Itaú. And again, those discussions led to many other interesting areas to explore. We also started building runbooks, and this was a real experiment here because as TAMs, we had seen that joining incident calls, sometimes we were not prepared, and we needed some sort of guidance in how to react. So the initial set were very scrappy as well, using dashboards, the dashboards we had created, links to that, internal links, tooling, fast tracking, escalation TTs and tickets, and so on. Our first set of alarms, again, very simple. We just wanted something that was very precise, that was aggregating across many of the services, and simple, something that we could continue to iterate over the course of the program. Again, the importance here was to make sure that the signal we were sending out was extremely precise versus noise. So with these dashboards, we had our first version of what we thought was the dashboard that we could present back to Itaú's leadership team. And we had a discussion with the CTO, and he said, "Oh, this is great, but it's not what I wanted. I still need to understand the application because these dashboards are great. They have a lot of information, but I don't understand this application. I don't know this application." And it's fair, right? It's impossible to understand how 4,000 plus applications work in a company. And the CTO also mentioned that they use Grafana for part of the infrastructure monitoring, and we were using CloudWatch. And then in this meeting, there was a term coined, farol, which we used throughout the remainder of the program. And I know many of you don't speak Portuguese. So the farol in Portuguese basically means traffic light. And the CTO said, wouldn't it be great if we had a traffic light system where green would mean that all my applications are running perfectly, availability is 100%. If it's amber, something's going wrong and we need attention from our engineers. And if that traffic light is red, we have a problem and we need to wake people up. So this is the first version of the farol, or the traffic light. And I think it did its job, right? Many of you here do not know anything about these applications, but you do know that there is a problem in one of them. And this is what we wanted to do. This is what the goal of the farol was, being able to give everyone within Itaú, from leadership all the way down to the engineering teams, an overview of the health of applications without necessarily needing to know how these applications work. And this is great. But what about drilling down? I mean, this is great to understand there's a problem, but where's the problem? So by selecting on those traffic lights, you can actually drill down into the specific components. And this is, again, a very small sample of what we're doing, but there's a lot of aggregation behind this. And this aggregation continues into dependencies. And you can drill down to very specific problems. So for example, this scenario was an incident that we were able to determine that it wasn't a service impact, that it was very isolated to one specific channel. And it really helped us to get to that pinpoint. So we were actually able to diagnose where the problem was and to investigate and remediate. Cool. So the traffic light logic, it seems all so simple, but it's not. There's lots of algorithms that are being used. And also, we see that metrics are not equal. We don't treat all metrics as equal. Aggregation is awesome, but weighting those aggregations is even better. Now we can really have some intelligent alarms and continue to build on these to have even further aggregation. And the point here is that we really just want to know where the problem is so we can start our investigations and start the remediation process. That's the most important thing of this whole thing. And I think for some of the next steps, it's Like, how do we automate this? Like, we're really looking into ways of auto discovery. So as new workloads come into AWS, we can set up premises, and those premises are metrics that we predefine and have auto discovery scripts create these dashboards. And then, application owners don't really need to do anything. They can go in and tweak the values and thresholds, but those dashboards are already there, and it's something that we're looking into, as well as simplifying this, because this is pretty complex right now, doing this. But it's been an awesome learning experience, and we've figured some ways out to improve the efficiency of creating these. I think everyone knows this one. Observability is a journey. I always say that it's a never-ending journey. We need dashboards are a living organism for the life cycle of that application. We need to continuously iterate. We need to continuously understand the lessons learned from incidences. For me, it's so important going back after having an impacting incident to understand what really happened and understand if the telemetry that we had in place actually worked, and learn from those lessons. Like, what worked in the dashboard? Did we alarm correctly? Can we improve the alarms? Are we missing metrics? I mean, sometimes we've created dashboards and metrics have been missing, and the application continues to evolve. We use new components, new services come out, and that's something that we need to continually do. And with this process, dashboards become richer. And I love the discussions when we have, it sounds a bit crazy, like I love the discussions after events, because we can all sit down to understand the lessons that we both can take in and see what we can improve. And so working backwards from that challenge, the third challenge on how we could improve support. So we really realized throughout this journey, the TAMs created dashboards, we don't scale. And these 4 workloads are super critical. You saw the volume of transactions. Extremely important for the Brazilian economy. Like, it's just a sheer amount of transactions. And we ultimately had been working internally with a team, passing this feedback on from Itaú. And this is why feedback is so important. And talking to your TAMs and to your SAs and to your account team, we were able to work backwards from Mota's team and Itaú to work internally. And recently, we launched the service that Itaú had a lot of participation in the inputs to this service, which is AWS Incident Detection and Response, or IDR. And we all sort of came to the conclusion that for these 4 critical workloads, enterprise support was not enough, and we really needed something like IDR. And the beauty of IDR is that now, when the traffic light starts alerting Itaú's teams, at the same time, they're alerting AWS teams. So we don't have to wait for Itaú to open a support case, to get an engineer assigned to it, for that engineer to get up to speed. Because IDR has runbooks. They understand these applications. They have all the dashboards that we built. Those runbooks that we started experimenting with, and we saw that we couldn't scale, IDR team are using these runbooks. And it's so much quicker now to get involvement from AWS. And I think there's a lot on this slide, and I don't want to cover everything, but there's just one really important aspect of it, which I love. It's the post-incident report. Through every incident, the IDR team will create a report, and that report has been used to feed the program, so the resiliency program. So we go back and look at the dashboards, we go back to see the alarms. Are the runbooks working correctly? Can we improve those runbooks? Can we reduce that time? Because again, the focus and the goal of all these things is to reduce that MTTR, to make sure that we can pinpoint that problem and investigate and remediate. That's the most important thing. Before we end this session, Anderson has a few closing words.